Hey everyone, welcome to this explainer. Okay, let me ask you a seriously critical question right off the bat. How exactly can organizations safely govern AI agents at scale when API keys are scattered everywhere and monthly costs are just an absolute mystery? It's a massive problem right now, and today we're looking at the solution.
Today, we're mapping out exactly how to secure, audit, and route tools like Claude Code. We'll quickly cover the AI governance nightmare, the SSH bastion concept, routing Claude safely, centralizing MCP tool access, handling rate limits and budgets, and finally, security and audit trails. Let's get right into it.
All right, Section 1, the AI governance nightmare. Let's dive right into the absolute chaos of AI adoption we're seeing across enterprise engineering teams. So how do we actually govern AI at scale? Because right now, it's kind of a mess. When every single developer and CI/CD pipeline is adopting AI tools directly, organizations are slamming into this massive visibility and security gap. You've got teams firing up Claude Code, Cursor, or building custom agents, but they're all just connecting directly to the upstream AI providers. And man, the nightmare unfolds fast. We're talking API keys just hard-coded into .env files, never getting rotated. Tool access is completely unconstrained. Literally, any developer can hit any model at any time. Then finance gets slapped with a surprise $50,000 bill. And if you try to ask, hey, who used Cloud Opus 4 last Tuesday and how many tokens did they use? Crickets, zero visibility. And worst of all, there's absolutely no audit trail for AI-assisted code generation that might be touching your production data.
Moving on to Section 2, the SSH bastion for AI. To fix this chaos, we need a fundamentally different architecture.
Enter ThinkWatch. Think of this as an enterprise-grade secure gateway. It proxies all your AI API calls and Model Context Protocol, or MCP, tool invocations through one single audited endpoint. Basically, it acts as a secure bastion. Just like you'd use an SSH bastion as the single choke point for all your server access, ThinkWatch becomes the single gateway where all AI traffic has to flow.
The key architectural shift here is actually super straightforward. Instead of granting direct access to OpenAI or Anthropic, your clients safely route their traffic through the gateway on port 3000. It acts as a multi-format API proxy, natively serving up both OpenAI and Anthropic formats on that single port. It's literally a drop-in replacement for tools like Claude Code, Cursor, or Continue. Which brings us to Section 3, routing Claude Code safely. Because the real test is how easily we can migrate an existing AI agent over to this secure setup.
Honestly, it literally takes two simple steps. First, instead of pointing your agent at the public Anthropic URL, you just swap the base URL to point to your new gateway host on port 3000. Second, you authenticate with a scoped virtual key, one that starts with a TW- prefix, instead of your real, highly sensitive credentials. Your actual Anthropic keys, they stay securely locked away in the gateway, fully encrypted at rest.
Now here is what's truly brilliant about this. That exact same virtual key unlocks both model access and tool access based on strict, centralized allow lists. You don't need a tangled web of separate authentication mechanisms. That one single virtual API key, which by the way is safely stored as a SHA-256 hash in the backend, handles the whole shebang.
All right, Section 4, centralizing MCP tool access. Let's see how this builds a unified, collision-free environment for managing your Model Context Protocol servers.
Look, without a gateway, running multiple MCP servers locally gets incredibly messy. Tools can easily collide if they share a generic name. But ThinkWatch automatically steps in and applies namespace isolation. So a generic tool called create_issue coming from a GitHub server automatically becomes GitHub___create_issue. This completely prevents those silent, frustrating collisions when you're aggregating multiple servers into one central endpoint.
And once you have that namespace isolation dialed in, you can slap on a 5-tier role-based access control system. This lets you dictate exactly who or which roles are allowed to invoke critical tools. For example, you could give a developer access to a Postgres query tool so they can look up data, while completely blocking them from a Postgres execute tool that could potentially wreck a production database. It's a total game changer for safety.
Okay, Section 5, rate limits and budgets. Now that access is secured and tools are isolated, we really need to talk about controlling token consumption and actually attributing costs.
ThinkWatch uses a Redis-backed engine to enforce two parallel limiters at the exact same time.
First up, you have hard sliding window limits. Think of these as your burst protection, like capping traffic at 60 requests a minute enforced pre-flight before the request even goes out. Second, you have natural period budget caps. These are your soft, calendar-aligned limits for long-term spend control, checked post-flight since we only know the final token count after the fact. Oh, and these limits stack, so a single request gets checked against the developer's personal cap, the API keys cap, and a global provider cap, all at once.
To make budgeting actually work across wildly different models, the system uses weighted tokens with input and output multipliers. So what does that mean? It means a heavy burst of traffic on a premium model, like Claude Opus, can be configured to cost 4 times more against a developer's shared daily budget than a cheaper many model. You literally just set a single monthly token budget, and it automatically scales based on how expensive the invoked model is.
Finally, Section 6, Security and Audit Trails. Let's look under the hood at the enterprise security architecture, keeping this entire bastion bulletproof.
The dual port design here is absolutely critical for keeping your attack surface as small as possible. All public AI traffic flows through port 3000, while your management console stays safely hidden away behind your VPN or firewall on port 31. By physically separating these concerns, external developers or tools have literally zero path to access your sensitive administrative settings.
But the security definitely doesn't stop there. Every single invocation is permanently tracked in high-performance SQL queryable ClickHouse logs. Your provider keys, deeply encrypted using AES 256 GCM. Plus, prompt PII is automatically redacted before it ever reaches the upstream model, swapping out sensitive stuff like emails and phone numbers for placeholders. It plugs right into SSO providers like Okta or Azure AD. It even has startup dependency validation, meaning the core engine flat-out refuses to boot up if your minimum security secrets aren't present.
So I'll leave you with this provocative thought. If your gateway went down today, would you know exactly which AI agents were accessing your production data right now? When AI agents have unconstrained access, visibility isn't just a nice-to-have, it is an absolute compliance necessity. That's exactly what makes this centralized bastion approach so incredibly powerful. Thanks for joining me on this explainer, and we'll see you in the next one.